So this stuff, again, overall should be pretty quick. And then y'all should have time to work, so you hopefully won't have much, if any, homework today, like to take home. All right, so proof and perpendicular lines. We're going to start with number 6. When you're doing these, you do need to copy down the picture. They're all like small. They shouldn't take up a lot of space. But these ones say to write the postulate or theorem that justifies the statement given that G is perpendicular to H. So, number 6. We know that G is perpendicular to H from the instructions. They tell us that angle 3 and angle 4 are right angles. And we have a picture here. 2 intersecting lines. H, this is G. They've shown you that that angle is a right angle. And then there is 3 and 4. And we're stating which theorem is justifying this statement. So there were 3 theorems in this section. And so the one that there were 2 that dealt with stuff being perpendicular. One was if we have 2 lines that form a linear pair of congruent angles and the lines are perpendicular. The other one is if 2 lines are perpendicular, then they intersect to form 4 right angles. So, which one of those 2 do you think makes the most sense for this one? Yep, it's theorem 3.3, which was the second one that I said. So on those ones, that's all you have to do is state the theorem. Again, none of these ones had like actual names, so saying the number is fine. But just as a reminder, when we get to theorems that do have actual names, you need to make sure we're using the actual names of them. 8. This is where we're starting to find the value of x. So 8 is, they give us a picture. And then so we have a picture that looks like this, and we're trying to solve for x. So if we know that this is a right angle or 90 degrees, we know that this also has to be, as we found, or as we saw in theorem 3.3. So that means that x plus 45 equals 90. So x is equal to 45 degrees. Just for reference, when you are, like if you're checking your answers in the back, they have a degree symbol on X, so they often don't write it over here. I'm not going to like be picky one way or the other. If you write the degree symbol, you write it. If you don't, you don't. But I usually write it just out of habit. But that way, just so you're aware. Like, if that's not going to like lose you points or something if you do or don't write it. 12. Got another picture. All right, so how would we set up our equation for this one?
X plus 60 equals 90 goes to the right angle somewhere.
Yep, x plus 60 equals 90. So x is equal to 30 degrees. The next one say, what can you conclude about the labeled angles? So with 14, we have AB, or segment AB is not congruent, wow, perpendicular to CB. And they give us this picture with it. So with this, the angles that they've labeled, so in this case for us it's angle 1 and angle 2, they want us to tell what has to be true about these things. Now some of them there could be multiple answers, so again, if you're checking your answer and they have something a little different than you have, that is possible that could be correct. So we'll try to talk about a few of the options on these ones. So what do you know has to be true about angle 1 and angle 2? Yep. The measure of angle 1 plus the measure of angle 2 is equal to 90 degrees. Can anybody think of anything else that we would know about them besides that? There's kind of two other like words that kind of like when I see that something's 90 degrees, I think about it. Huh? Complementary, and I think somebody said right angle. Yes, so angle 1 and angle 2 form a right angle. Like if they're added together, obviously not each one individually, but like together. And then angle 1 and angle 2 are complementary. So you don't have to write all of these things. Like the book only put for their answer that angle 1 and angle 2 are complementary. Okay, so it's fine. You only have to have one of them, but it's probably good while you're working through this stuff if you try to write down as many things as you know about those, just to like get used to it. But as long as you have one, you're good. Another one like this, 16. H is perpendicular to K. All right, so again, they want us to say what we know about these angles. It could be talking about one of them at a time. We could be talking about all of them, or just two of them. But again, there's multiple things here that I can think of that we can say to be true. But what do we know about these angles? What's something that we could say? Like all of them together? Yep. Angle 1, angle 2, and angle 3 are supplementary. What else?
1 and 2 are complementary.
Yep. Angle 1 and angle 2 are complementary. Now, if you talk about angle 1 and angle 2 only, you also need to say something about angle 3 because you have not fully answered the question. So what's something we can say just about angle 3 that would kind of like satisfy?
Right angle.
Yep, angle 3 is a right angle. Out of curiosity, why? Because it's not marked that way.
The measure of angle 1 plus the measure of angle 2 equals 90 degrees, so the measure of angle 3 equals 1.
But how do you know that angle 1 and angle 2 are 90 degrees?
Because 3 is guaranteed a right angle.
How?
Because H and K are perpendicular.
Yes, H and K are perpendicular. So using the theorems that we have, if they're perpendicular, that means that these have to form right angles. Okay? So yes, I know that y'all are seeing them, but I want to make sure that we understand the reasoning because that's going to help us when we get to the proofs later on. Abby, what was the thing that you said again about angle 1 and angle 2 or something like that?
I said the measure of angle 1 plus the measure of angle 2 equals 90 degrees, which means that the measure of angle 3
Yeah, that's fine. Yep. So those are just a few options. I'm not saying that there aren't some other ones. We could say that because we've said they're supplementary, we could say the measure of 1 plus the measure of 2 plus the measure of 3 equals 180 because of them being supplementary. But all of those are options. We could say the measure of 1 plus the measure of 2 is equal to the measure of 3. That's another option, but I'm not going to take time to write all of those things out after I'm done teaching. We only have one example left. All right. So the last one, just so that you have seen a flow proof, is going to be one that's a fill in the blank flow proof from your book, okay? Where we're filling in kind of the gaps. So I'm going to go through and set it up, and then we'll go back through and kind of like fill it in. So in problem 18, they tell you that the given information is that J is perpendicular to K, and then they tell you the angle 1 and angle 2 are a linear pair. We're trying to prove that angle 2 is a right angle. And they give us a visual. This is J, this is K. All right, so again, I'm going to go through and write in all the stuff that they tell us. I'm going to put blanks where we're going to fill things in. So the way a flow proof works is typically you're going to have like, or at least the way the book's going to set it up, they're going to have something in a box, which is going to be your statement, and then your reason is going to go underneath of it. Okay, now I'm not going to draw, well, I might draw boxes around this stuff just so it's easy to see, but I just want you to be aware of that. So I'm going to write this stuff first, then draw boxes around them. All right, so my proof, and there's going to be like multiple pieces to this. Have y'all seen like a flow chart before? Where it's like, you've probably seen one in science, maybe with like the water cycle or something,
Yes.
where like it has like, I'm not good with the water cycle, but like you have like a body of water, and then it shows it like condensating, or whatever the word is, evaporating, I guess is the right word, evaporating, and then it like is going up into the clouds, and then it's like falling around, and you ultimately come down with it raining. It's like basically a bunch of circles with arrows like that.
Yeah.
This is gonna look like that. It's just in for a proof instead. All right, so the stuff that they give us, angle 1 and angle 2 are a linear pair. So that would be what's in the box. That would be the statement. I'm going to write their reasons in blue just so that we can see. And that would be because that's a given. Over here, J is perpendicular to K. Their reason for that was also given. Once we do this, you're going to see why I'm not making you actually do these, aside from if you just had to fill one in that was given to you. Then there's an arrow drawn down. This box we're going to be filling in, so I'm going to leave it blank. The reason for this one is it is the linear pair postulate. So we'll fill all of them in a minute. Over here, angle 1 is a right angle. And they give us the reason for this one. It's the definition of perpendicular lines. Keep going down on this side. The next thing, the measure of angle 1 is equal to 90 degrees. We're going to be filling this in, so I'm just going to draw a blank here for what it's going to be. Over here, the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. We're going to be filling in that reason also. gonna go back and label. This is A, this is B, this is C. Then this is where these things meet over here. They're both gonna come down together and meet on this next thing, which is that 90 degrees plus the measure of angle 2 is equal to 180 degrees. This is going to be a blank that we're filling in as well. They then come over this way. There's going to be a box that we fill in. Why did I not draw a box? That's going to be E. The reason for this is the subtraction property. Yeah, it's of equality. I'm just not writing the of equality part for space. And then the last thing, which is what we're trying to prove, is that angle 2 is a right angle. And we're finding the reason for this one. All right, I'm gonna let you get all that, and then we'll go back and fill it in. All right, so if angle 1 and angle 2 are a linear pair, okay, that was given information. And this step, the reason is the linear pair postulate. What might be going here? What is the linear pair postulate basically telling us? You don't have to give me like the exact words, but.
Take everybody equal 180 degrees.
Nope, not what I'm looking for. The linear pair postulate says if two angles form a linear pair, then they are supplementary. So what must be true about angle 1 and 2? They're supplementary. So angle 1 and angle 2 are supplementary. So then, knowing that information, angle 1 and angle 2, I feel like that looks like a 2, are supplementary by the linear pair postulate, then we can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. What allows me to say that?
The definition of supplementary.
Yep, definition of supplementary angles. I'm going to abbreviate. All right, the next thing is over here, but I'm going to go back and just talk through this. So they told us that J was perpendicular to K. That was our given. Angle 1 is a right angle. That was seen here, but it's also the definition of perpendicular lines, okay, is that those have to form right angles. So then we know that the measure of angle 1 is equal to 90 degrees. What's the reason for that? Yep, definition of a right angle. Right angles. All right, so knowing both of these things here now, the measure of 1 plus the measure of 2 is 180, and the measure of 1 is 90. I take 90 and I replace the measure of angle 1 with that. Then what would have to be the reason here for why I'm allowed to do this?
Substitution.
Yep, substitution property. So then if the next step, the reason for it is the subtraction property, what has to go in this box?
The measure of angle 2 equals 90 degrees.
Yep. The measure of angle 2 is equal to 90 degrees. And then following it down from there, angle 2 is a right angle. What's the reason there?
Transitive property? Or is it the
Definition of
Yep. Definition of right angles. So the definition of a right angle can work both directions. Okay, it can work when we're told that it's a right angle going to 90 degrees or when it's 90 degrees going to being a right angle.
Oh, I thought it was
What?
I thought it was the A equal to, or A is equal to B and B is equal to C.
But we don't have that situation. You would have to have something like 1 is equal to 2, 2 is equal to 3, so 1 is equal to 3. But we don't have that in this problem. A lot of people I noticed on the test used the transitive property in a lot of places that it didn't make sense at all. Okay? So y'all need to make sure that you're going back. Those things should have been in your theorem and postulate books anyways. But you need to make sure that you're going back and you're looking over what all of those things mean so that you don't continue to have issues with them. Okay? Like the reflexive property, there were a few people that were putting reflexive for things that were definitely not reflexive. And if you just looked in your theorem and postulate book, it should have been obvious that it wasn't reflexive. Okay? So make sure you're going back through those things because you don't want that to be an issue going forward for you. Okay? And that's across the board. Many people had issues with that. All right, any questions about this? Again, you would not have to draw one of these yourself. I just wanted you to see what it looks like and why we like to just do our 2-column proofs because they're much easier. All right, problems are 3 through 19 odd. Only one of those is a proof, I think. Or, well, one is a paragraph proof and you're filling in the blank. So basically what we just did here, they make a statement and you're either saying the reason or like what it's equal to. Okay? It's pretty easy. And then the 19 is a 2-column proof. But again, the process of it is similar to this. Obviously, you have a reason and you're filling in and it's a fill in the blank one.
So for the fill in the blank, can we just put like A, B, C and just like see the answer for that, or do we have to write out the entire thing?
For the, like with number 17, which is the paragraph proof, I would suggest everybody listen because you're going to end up doing this wrong and then you're going to get points off. Number 17, you can just copy the actual proof part and then just fill in the blanks. Just like either underline or circle the words that you're filling in for like the A through F. For the 2-column proof, you just need to copy over the proof itself, but you need to have it all. Like you need to show statement and reason. I don't want you just doing A is equal to this because then you're not really paying attention to any of the stuff in my opinion. All right, and then also on here, some mixed review to keep us ready for our quiz is 29 through 36 all, but they're really easy. It's just off the stuff that we did basically yesterday and a little bit from last chapter. So, yes, Jonathan.
So for the paragraph proof, we can just like write the statement as to why and then just have the reason right next to it instead of writing the whole paragraph.
No, that's not at all what I said.
I didn't quite understand what you said.
I said fill in the blanks in the proof as you write the proof. It says because BA is perpendicular to BC, angle ABC is a, so I would write all of that, then I would fill in the blank, then I would, and the measure of angle ABC is equal to blank, I'd fill in that blank, but you're writing that entire statement is what I said.